Hello and welcome to my channel. This is going to be an exciting question in physics and I hope you enjoy your stay. Alright, this question said a solid material has a volume of 30 centimeter cube and density of 2.5 grams per centimeter cubes. Then it says it is suspended from a spring balance with 1/3 of its volume immersed in water. What is the reading of the spring balance? They say the density of water, it's 1 gram per centimeters cube, and it's a wire question, right? So let's start. Solution. So this is under density and upthrusts. Okay, so what are we looking for? They say we should calculate the reading in the spring. Now we'll start with that. Reading in the spring, right, is equal to the real mass of that material minus the upthrust, and the upthrust is that its mass when it is immersed up to 1/3 of its volume in water, right? Okay, so how do we get the real mass and how do we get the upthrust, right? So let's see the real mass. We know that density which is rho is equal to mass over volume, right? So if we are dealing with this material, this very material they are giving to us now, what is our mass? What is our volume? They gave us the mass to be 2.5 gram per, they gave us density to be 2.5 gram per centimeters cube, and they gave us a volume to be 30 centimeters cube. So if you substitute value, we're going to get the mass, right? So mass will be equals to density times what? Volume, right? Okay, so this is going to be density 2.5, volume 30. So this is going to give us what? Let's multiply the values. Let's get our value. Calculator. Alright, 30 times 2.5 is going to give us 75. So we have 75 grams. Okay, so we have gotten the real mass, right? And this is going to be our real mass of the object, of that solid material. Now what is left is for us to look for the upthrust. Okay, so upthrust, right, is given by this level at which the immersion took place, which is 1/3. So if you have n representing that times the volume in which that object is immersed inside times density, right, of that water in which it is immersed inside. Okay, so if that is understood, so this n now is 1/3, that is the level at which it is immersed is 1/3. 1/3 is 1/3 times the volume is what? 30 times the density. The density of water is 1 gram per centimeter cube. So 1. So 3 here, 1, 3 here is 10. So we are going to be having 1 times 10 times 1, and that's going to give us what? 10 grams. So if we have gotten 10 grams, in case we want to leave our reading in a mass, we'll just say reading in spring is going to be what? Real mass 75 grams minus up thrust. Up thrust is 10. So it's going to give what to us? 65 what? Grams. But then our spring balance, there are some ones that have their readings in grams anyway, but we always have the common one have their readings in Newton, right? They have their unit in what? Newton. So let's do the conversion now. 65 grams. What is it going to give us as the what? Value in Newton. So if 1 Newton is equal to 100 grams, right? So x Newton will give us the 65 grams, right? So let's find x. Is cross multiply. This times this will give you 100x. This times this will give you 65 Newton. So x is equals to 65 Newton divided by 100. So it's going to give you what? 0.65 Newton. So that's our Newton. Our value in Newton to be 0.65. Okay, so you now end by saying, hence, the reading of the spring balance equal to 0.65 Newton. Alright, that brings us to the end of this calculation. I'll see you in other videos. Bye for now.